quadratic function. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. A quadratic function is a function of the form a, b, and c are real numbers. The graph of a quadratic function has a curved shape known as a parabola. The simplest quadratic equations for a quadratic graph are y is x squared, a equals 1, b and c are 0, and y is minus x squared, a equals minus 1, b and c are 0. Now let's draw the graphs. Take the equation y equals x squared to fill a table of coordinates. Plotting these coordinates and joining the points together, we get the parabola. Take the equation y equals minus x squared to fill a table of coordinates. Plotting these coordinates and joining the points together, we get this parabola. The first important feature of the graph is that if the coefficient of x squared is positive, the parabola will open upwards. And if the coefficient of x squared is negative, the parabola will open downwards. When we learned to draw straight lines graphically, we did so by preparing a table. Then we learned that with just 2 points we could draw a straight line graph. A similar approach is used for graphing quadratic functions. These graphs, however, can seldom be drawn properly by plotting only 2 or 3 points, because the graphs are curved lines. 3 points will almost certainly not be enough points for graphing a quadratic function. But these graphs have important features that allow us to draw them rapidly. Now that you have been introduced to the graph of the quadratic function, we begin by looking at the graph of the following quadratic function for the other features. Let's see the general properties of the graph of quadratic function. Vertex. Vertex is the point where the graph turns. Vertex is called the turning point as well. X-intercepts are the points where the graph crosses the x-axis. These points are the roots of the quadratic equation. Therefore, we need to solve the quadratic equation to find the x-intercepts. Axis of symmetry is a vertical line that divides the parabola into 2 congruent halves. The axis of symmetry always passes through the vertex of the parabola. Y-intercept is the point where the graph crosses the y-axis. The y-intercept value is equal to the value of the constant term in the equation itself. The vertex is the point. The x-coordinate of the vertex is minus b over 2 times a, and the y-coordinate of the vertex is f of x of the vertex. If a is positive, then the minimum value of f of x is y-coordinate of the vertex. If the graph opens upwards, the y-coordinate of the vertex is the minimum value of the function. If a is negative, then the maximum value of f of x is y-coordinate of the vertex. If the graph opens downwards, the y-coordinate of the vertex is the maximum value of the function. Now look at the graph above. Let's see how it works. Draw the graph of f of x equals 2x squared plus 4x minus 6 and find the domain of the range of function. Solve the equation to find the x-intercepts. The roots are minus 3 and 1. Locate these points on the graph. Get the y-intercept simply by looking at the function and take the constant term. The constant term is minus 6. Plot this point on the graph. Find the vertex. X-coordinate of the vertex is minus 1. Find the y-coordinate of the vertex. The y-coordinate of the vertex is minus 8. Plot this point on the graph. Draw the axis of symmetry and draw the graph. The domain is all real numbers. Since the graph opens upwards, the y-coordinate of the vertex is the minimum. In other words, the y-coordinate of the vertex is the lowest y value for the function. Pay attention. Draw the graph of function and find the domain and range of function. First, solve the equation to find the x-intercepts. The root is 2. Plot this point on the graph. Get the y-intercept simply by looking at the function and take the constant term. The constant term is 4. 4 is the y-intercept. Find the vertex. X-coordinate of the vertex is 2. Y-coordinate of the vertex is 0. Draw the axis of symmetry. Draw the graph. The domain is all real numbers. The graph opens upwards. The y-coordinate of the vertex is the minimum. So the y-coordinate of the vertex is the lowest y value for the function. This is the range. Draw the graph of function f and find the domain and range of f. Solve the equation to find the x-intercept. We will not be able to factorize this equation, so we use the quadratic formula. Delta is negative, then the square root of delta is not a real number. The equation will have no roots. Get the y-intercept. The y-intercept is minus 11. Find the vertex. Plot the points. Draw the axis of symmetry. Draw the graph. Domain is all real numbers. The graph opens downwards. The y-coordinate of the vertex is the maximum. So the y-coordinate of the vertex is the highest y value for the function. This is the range of the function.